Lab 5, Coefficient of Friction. Introduction. The purpose of this lab was to observe the motion of an object with friction rolled down a board at an angle to understand the coefficient of friction. The main principle we were trying to observe was Newton's second law. Newton's second law / the momentum principle states that the net force is directly equal to the rate of change of an object, and also that F equals ma. Model. Here we can see a brief preview that in both the predicted model and the observed model, that the x position versus time is increasing and that it is curved rather than linear. This means that the eraser does not have a consistent acceleration, which makes sense since we know there is some amount of friction occurring. System and surroundings. So our system was just the eraser, and our surroundings are the whiteboard, gravity, and the lab partner. Initial conditions. The initial position of the eraser was R initial equals 0.03078989 in the x, and 0.05084545 in the y, and 0 in the z meters. The initial velocity was vi equals 0.31161 in the x, 0.000972 in the y, and 0 in the z meters per second. From Tracker app, we got that the theta equals 28 degrees by using a protractor, and then just using an estimate, we got that A average is equal to G sine theta. So using that angle of 28 degrees, we got that acceleration average equals 0.11191 meters per second squared. Experiment. We started by grabbing an object that we knew would have friction, which was the dry eraser. Then we set up the whiteboard at an angle. Then we put the eraser at the top left corner and gave it a little push. Then, using Tracker, we got data points. From there, we input the data into our code. Also, FYI, we used the top left corner as the origin with the axis of x going on top of the ramp. Code. So I input the initial conditions that we talked about at the top. Then, because of Newton's second law, I set the different forces equal to net force and solved for mu from the friction force. So I got that mu equals tan theta minus acceleration divided by gravity times cosine theta. Then I got delta t just by averaging from my data as 0.01. Then I put this information into a loop for the time the experiment ran to get a computational model based on how the motion would be affected by mu. Here's the output of the code with a position and a velocity. So in our position graph, we can see that it indicates that the acceleration is decreasing, while the velocity shows that the acceleration is deaccelerating at a constant rate, which makes sense since our mu isn't changing. Differences and similarities in predicted versus observed data and reasons for error. Some differences is that the computational model has a much smoother curve and is a little more curved. Some reasons for this error is that when one of my partners pushed the eraser, they could have added a force not accounted for. Another might be that the board wasn't perfectly smooth and so the motion was not smooth. Additional questions. What if when the eraser was sliding on the board, the mu was 0? If the coefficient went to 0, then the friction would also go to 0. So by Newton's second law, since we lose one of our forces, particularly friction, which acts in the opposite direction as the others, the eraser would slide down quicker. What does this mean? Under the same conditions if the eraser stayed at rest. By Newton's second law, if there was no movement, that would mean that the net force equals 0, which means that friction with the mu would equal gravity and normal force. Thank you.